We are finishing up section 15.1 with this video, and we are going to take a look at examples 3 and 4, and we're still factoring. The problems are getting a little bit different here. With example 3, if you notice, it's a binomial, so it has two different terms, and in each term, it has a parenthesis with an m plus 5. So they have an m plus 5 in common. So we're going to take that away and put it in the front. And then that's gone. That's what they have in common. And then we write what is left over. There's a 3m in the front and a plus 4 at the end. So that is your factored expression for that problem. Same thing here. They both have a b minus 3. So we factored that out. And then the first term has a 16b. And then there's a minus sign, but there's no number out front of that second set of parentheses. So it's just like a -1. Remember, we don't normally put the ones there. So that is what's left over from that. And that is our final simplified version. Now moving on. Example 4, we have to factor by grouping. So what that means is that there's going to be 4 terms. So we're going to group the first 2 together, and we're going to group the last 2 together. And we're just going to focus on the first group for a second. So 2x to the third and 8x squared. So 2 and 8 have a 2 in common. And x to the third and x squared, they would have x squared in common. Now we write what is left over. So 2 divided by 2 is 1, and x to the third divided by x to the second, we would just have 1x left. And then 8 divided by 2 would be 4, so we have a 4 left. And then x squared divided by x squared is 1, so no x's left over there. Then we do the same thing, but with the second set. So 3x plus 12. Well, 3 and 12 have a 3 in common. And 3x has an x, but 12 doesn't, so there's no variables in common. And 3 divided by 3 is 1, so just that x is left. And then 12 divided by 3 is 4. So that is partially factored. Now if we look at it, we notice this is very similar to the problems in example 3. They both have an x plus 4 in common. So we are going to take that out, factor that out. And then we have to write what is left over. The front has a 2x squared, and the back has a positive 3. Then we are completely factored. And as you noticed, I didn't do the factor trees for this. If you want to do those, you're more than welcome to do those. If they help you see what's in common and what's left over, absolutely go ahead and do so. All right, for our last one here, again, it's a group of 4, so we're going to break them down into 2 pieces. 12 and 15 would have a 3 in common. And n to the third, n to the second, they would have 2 in common. 12 divided by 3 would be 4, and we took 2 n's away, so there's only 1 n. And then minus 15 divided by 3 would be 5, and we took the n squareds. And then for the last set, 8 and 10 have a 2 in common, and they don't have n's. So 8 divided by 2 is 4. Negative 4 is a -8. We didn't take the n, and 10 divided by 2 is 5, so plus 5. So now what you notice is that what's in the parentheses is opposite. They're exactly opposite. So what we're going to do is factor out a -1 out of that second set. So if I divide everything by a -1, I have to bring that out with that 2. So that 2 was positive. Now it's going to be a negative. That 4 is going to be positive, and that 5 is going to be negative. So I divided everything by a -1 there. And now you can see that our parentheses are the same. So they have that 4n minus 5 in common, and they have 3n squared minus 2 left over. And that is our completely factored answer.